Hello and welcome boys and girls to Mr. Nice Guy channel. On today's video, we will explore more in detail on the crash simulation using the Hypermesh. Okay, in this second round, it involves using your material stress strain behavior into your simulation, which is done by a few simple steps. But first, you have to get this app that called Engage Digitizer, which you can Google it, Engage Digitizer, and go to the link given. And once you're at the home page, click the latest release and download for Windows 10, 64-bit. Click this link and you will download the installer. Okay, once you download and install the file, you can open it. Open the engage digitizer. Okay, you will be, this is the apps. Okay, but before you can start using the digitizer, you must have the, let's say, the material property, the true stress strain diagram of your material that you chose. And for this simulation, I have here with me is aluminium alloy 6061 true stress and true strain diagram. This is the diagram that you wanted when you Google for your material. Okay, find your material properties, look for the true stress diagram, and you can just screenshot the diagram and save it in your computer. Okay, once you've done this, open up your Engage and go to File, Import, and import your earlier image. Okay, import, go to the file. Okay, find your image file and then open up. Okay, for first time user, you will be greeted with this checklist guide wizard, but you don't need it since you are watching this video. Just click cancel and click here, the three red dot. The first point is the axis, the origin. Click and put the origin number, which is 0 and 0. Next is 0 point, the next axis, which is 0.2 and 0. The next, which is 450 and 0. Oops. Okay, so you will, once you put these three value down, you can go ahead and analyze by clicking this green line. Okay, once the scanning is done, you can hover the graph, and if your graph change color from original color to greenish color, it, it tell you that you have successfully converted this image into a digital file. Okay, click it and you have the point already automatically plotted for you. Okay, once this is done, you can export your file. Go to file and export. Go to your desired location that you want to save and put a name on it and click save. Okay, once you save, you have something that look like this. Okay, you have a data of with two column of numbers with value on each side. Okay, this value is what you need in the Hypermesh. Okay, so once everything is done, congratulations, you just finish your first step in making this simulation. Okay, click. Okay, close everything else that you don't need. Okay, so open up your Hypermesh. So some Hypermesh take longer to load and some are faster. So be thankful that mine is slightly faster. Okay, so like usual, we are going to use radius. So go to file, import your model, and for me, I'm going to import my nope, import, and I import model, import geometry. Okay, so let's do it again. File, import geometry. So we are going to import the geometry, which is the IGES file, if you remember, the original IGES file, my chassis and my crash bow. So I'm importing both of them into my Hypermesh. Okay, and then you at this stage you can translate, you can move around your crash, your pole into closer to your chassis by going to the tool and translate component and translate. So I'm going to put it as close as possible to my crash project. So okay, this is it. Can view them now. Okay, this is my project, my chassis and my crash pole. Okay, you don't need this anymore. Close it. Okay, the first step is like usual. We wanted to create the meshing first, but for this tutorial, I'm just going to mesh this side only. So the rest you can follow the original video on the previous simulation. Okay, so create my component, let's say aluminium chassis. Okay, from this, so I'm going to 2D auto mesh surface, click by collector, my first collector. Okay, element, change it to current component. You can use mix, artrias, whatever you wanted. This depend on your geometry. If it is simple, just use quad. If you think your geometry is complex like mine, you can use artrias. Okay, mesh, let it load. Okay, and mesh. Element size should depend on you. If you wanted 5-hour analysis, you should go for smaller element size. But if you want to run the analysis within 1 hour, 20 should be fine. Okay, mesh and return. Okay, so you should have something that look like this. Okay, so let's see. Now is the moment that we are going to use the curve that we made earlier. So from this, once you have the mesh already done, right click, go to create and go to curve. Okay, from this you can see it will pop up a new menu. So just click new and put a name. Let's say aluminum 6061 in the case of my material. Go click to proceed and go back to your curve editor and open up your file, Excel file that you made through the engage digitizer. Okay, this step is fairly straightforward. Just copy and paste, select your value for X and paste, and select another for paste. Okay, click update. Okay, you should have a graph that look exactly like your graph in the engage digitizer. Okay, if it looks somewhere something else, please view this video again. Okay, so click, once you're done, click update and close. Okay, notice that here we have a curve under the name of Alumina 6661. Okay, from this you can put your you can edit your value. close. Okay, for the curve, okay, it's time to make the material first. This is the curve that you will apply the behavior toward your material. So now let's create the material. Say material name is aluminium 6061. Type all, cut image. Please find M36 plus tabulation. Click that and create. Okay, once you create, you can edit the value, which is the Young modulus, the Poisson ratio, the density. You can just look it up in the Google. Okay, for my case, I have the value here, which is the density, the Young modulus, and blah blah blah. So go back to your, just put the value as usual, three value, which is the density, the Young modulus, and the Poisson ratio, and then scroll down and find n function. N function, you put 1 here and click on the icon table there and click unspecified, click another one curve and find your aluminium, click OK. Okay, next, F scale, change it to 1, and epsilon dot is your strain rate. Okay, strain rate you can get it from Google. So from for my material, I've Googled it and someone suggested using 50 for my case. My strain rate says okay, close, and put the value here. Okay, once you're done, put all the value here. You can go to view, browser, hyperwork, no, Hypermesh, browser, Hypermesh, and solver. Okay, once this open, you can right click here, create. But before you create anything, just open up the solver first and let it be there. Go to utility and engine file assistant. Okay, we wanted to create the cut image first. Okay, the termination time is how long your animation going to run. Let's say 0.015, and animation output frequency should per 10 from your termination time, which is 0.0015, and the time history output frequency, you divided the animation time by 10, again 0.00015. Okay, generate output request and click OK. Okay, then you should see the cut here. Okay, so check everything is an engine run and entity and t file. Okay, everything should be as according to the value you put earlier. Go back to the solver and you can see here we have engine keyword, the new engine keyword. Okay, from here just click, go to create and find TH, which is stand for time history. TH and go to node. Alright, oops. Okay, if you're wrong, right, delete it, create some more. TH and go to node. Okay, the output block. Okay. Click here, we're going to add the entity ID to your crash part. One note to mind is that you should put this note where you think the actual crash might happen. It will provide a better result for your graph later. So click notes, and notes, just click one point that you want to be as a reference. So click, for me the crash will take place at the node I just clicked. So I proceed. So the number variable, put it as 1. Click the table icon here and put DEF all in caps and close it. Okay, That is done for the output block, and then go to engine keyword, go to animation, anim, and animation vector, anim vec. Open up and ticks as according to my uh, wait a second, let me see which one you should tick. Okay, 1 2 velocity, pecan, vex, contour, FOPT, and free AC. Okay, just tick as according to what I tick here and you should be good. Okay, so this part is the first part of the additional component from the previous video. Okay, if you follow this step with the added step from the previous video, you will have something that look like this. Okay, so let's see. Okay, I have my all my 13 card here with the value as I generated from the engine assistant. So I have my three component, my steel pole, my crash element, my curve earlier, and it should, okay, then from the output block that you made in the previous session will pop up here. Okay, and then if your setting is all good, you can go to analysis and radius and click run. Okay, once you run the radius, which took around 1 hour for me, so you will have a result. Okay, okay, my result looks something like this. Okay, now for the crucial part is this is a simple simulation which is everyone can do, but the problem is how to extract the graph from the simulation. So first thing first is that you are going to run a simulation of, go to contour here, click here and change this to von Mises, and you want to hide everything else except for the chassis, the main component that is crashing. So close, hide everything else, leave it as just one part, and click the component, click display and click apply. Okay, averaging method, change it to simple and apply again. Okay, play the simulation, and then, okay, it is important that you follow step by step, which is first is stress, followed by displacement, and followed by strain. So first we do it the von Mises first, and once the simulation run, go to click this icon which is measure, click this measure, tick dynamic min max result, change it to max and create curve. Okay, the create curve window will open and click OK. So you will have your, this is stress versus time graph. Okay, you can stop it, the simulation first, and then go back to your contour, change this value to displacement, component again display, resolve in global, and click apply. Okay, play the simulation first and then go to measure. Okay, at this part click add and change distance between two nodal contour. and notes. Okay, notes by ID. Okay, remember that the point that I mentioned earlier that you made for the output block. Okay, let's pause first, go back to the Hypermesh, then go back to your output block that you made and click the note. My god. Oh, wait a second. Not the note, cancel. So go to your number of row 1, click here, the second table. Okay, you see no ID, not ID mean your node ID that you made earlier, the point as the reference. So remember this number 1198. It will different between you and me depending on the point that you make. So close it, go back to your hyperview, node by ID, put it 1198 and click OK. So play the simulation and create curve. Okay, new plot. Okay, the second plot is the displacement, as you can see here. This is the displacement, this is the von Mises stress. Okay, you can stop the simulation now. Okay, one important thing is you must just click on the empty space in the graph section. Click here and the interface will change to hypergraph. Go to file, load and preference file. Go to vehicle safety 2 and click load. Okay, once you load, you notice that we have extra menu up here. Okay, we wanted to combine this graph and this graph together. Okay, so go to map, go to two curve and cross plot. Okay, you don't have to change anything here, just double click on the x should be the displacement, as you can see here, the displacement, and the y should be the von Mises stress. Click OK. Alright, and then for the layout, go to create new layout and one curve per plot. It should be fine here. Just click apply. Okay, this is the combine between displacement on the x-axis and stress on the y-axis. Okay, from this you can export this the data of the graph into a usable value. From just click this button here, the arrow, go to export curve. Okay, from this export curve, you can save your location, the location of your file into whatever that you want. Just put the name. For this is stress versus strain, stress versus displacement. Put it stress displacement and click save and click OK. Okay, change it to current page. Before you click OK, change it to current page. We wanted this page only to have the value. Okay, so click OK and you will have something that look like stress displacement. You will have something that look like this value. Okay, what this value mean is the same as the value in the hyperview. If you plot it here, you will have exactly the same graph as the in the Hypermesh. So save it first. Okay, so this is the second page. Go back to the first page, and then we wanted to add strain versus displacement. So click on the empty space in this section. So go back to contour, change it to strain, plastic strain, component, display, average method, change it to simple and apply. Okay, let the simulation run and then go to measure again. Okay, this time we don't want to use the measure group 3 anymore. Untick this and go back to dynamic min and max result. Click the max and create curve. Okay, new plot. Okay. Okay, this dynamic, the second one dynamic is the strain. Okay, as you can see here, plastic strain scalar value. So from this, we are going to make the same thing, which is to click at the empty space here, go to math, to curve and cross plot. Okay, the same thing. The x always going to be the displacement, and the curve is going to be the plastic strain. Okay, so create new page and click apply. So you will have something that look like this, and then we can go back to export curve, save it wherever you want with the name strain displacement graph or whatever you want, and click save. Make sure you change it to current page and then click OK. Okay, then you will have another graph named strain displacement. Okay, as you can see, if you plot this graph, you will have the same graph as the hyperview back there. Okay, so that's it about how to create a graph. But the graph that you wanted is number one, the load displacement. Load displacement is the same thing. You go back to your first page, stop the explanation first, go to contour, plastic strain, you find your contact forces and component display and resolve in global, and then click apply. Okay, let it play a while. Okay, so you're going to again measure, go to dynamic min and max result, click max and create curve. Okay, so you have another curve of forces versus time, which you want to combine again with the displacement that we made earlier, which is this one. We wanted to combine it by going to click the gray empty space here, go to math, go to curve and cross plot. The x is always going to be the displacement, and the y is depending. You wanted the contact force, plot it with the contact force. Okay, so create new page and click apply. So this is the force versus displacement graph. Okay, so once done, stress strain contour done. So stress strain displacement. Okay, if you wanted to combine both stress strain displacement into one graph, there is simple way you can do it, which is just from the Excel. Okay, let's say from the earlier combination that you make, which is the strain displacement and the stress displacement. Okay, open up both of these graphs. Okay, okay, this is the stress and this is the strain. Okay, you wanted to combine this into one table. So what you want to do is that in both in both Excel, just make a graph. Okay, insert, go to scatter, line scatter. Okay, and the same thing, do it with the strain Excel. Okay, so you want to combine this into this. If you directly combine, you will see that the value of the strain is very small. You will not see any change here. However, we can change that. The first step is that you click on the graph of the strain or the stress, whichever you want. Just click one click Ctrl and C, copy, click on the second graph and click paste, Ctrl V. Okay, you should see the color should change, and click the line, not the axis but the blue line. Okay, should be something that look like that, and right click, go to format data series, go to secondary axis. Okay, once you've done that, you should see that this side is the stress and this side is the strain, while sharing the displacement on both graph. Okay, this should be the stress strain displacement graph. Okay, for the internet energy, you can go back to your hyperview, go to the first page again and click this window, go to contour and change to, if you can see internet energy anywhere. Nope. Okay, which means you cannot do it here. If you cannot do it here, you can build plot. Okay, from this, from the load case. Oh no. Okay, go here, click somewhere here, and then build plot. Oh, okay, here, build plot. Okay, click anywhere on the empty space in the graph window, click, and then go to build plot. Okay, click, open up your file. Okay, the first thing the important thing you must remember here is that where you save your file earlier. Okay, if you save your file here, you go back to your file and you must find the TO1 file here. You want to load this file. This is the time history file. Okay, click here and click open. Okay, from this you can see that the file, the graph that you make, the output block that you made earlier in the Hypermesh. This is the file that it produced. So the X should be time, and the Y axis should be whatever you want, global variable, can, internet energy, magnitude, and you just hit apply preview. Okay, if you hit preview, it will combine with this. So please make sure you make it this one first before you taking a step into other part, which is the stress, the strain, the displacement. Okay, make the table for this one first, and then you should good to go. Okay, so I hope there will be no problem anymore regarding crash simulation. And please, if you have any more questions, do free to text me or leave a comment in the comment section below. Okay, thank you, and I'll see you again. Goodbye.